The agenda for today's session is we will start the session with an introduction about what is synthetic data, what are all the different problems the companies face, and when and where the synthetic data is actually used, and what are all the different approaches that we can use to generate the synthetic data. Whereas we look at what are all the different types of frameworks and tools which are available, and we will take a couple of frameworks which are available in the market and have a detailed discussion and demo of those frameworks, how it is actually helping us to generate the synthetic data. Towards the end of the session, we will have a look at what are all the different applications or the use cases of synthetic data. These are some of the use cases which are already been implemented at various companies. So welcome all to all of you again. So before we start, let's give the context when it comes to companies, what kind of a problem that they face in terms of their AI application development. One of the basic problem is it is very hard for the companies to collect real data as such, which is a very time consuming process. If you consider any machine learning application development, more than 60 to 70% of the time goes on your data collection, data fine tuning, and data cleaning, and so on and so forth. And apart from that, when you want to put forth your data, there could be a lot of constraint from the regulatory perspective as well. Your data could be containing some personal identifiable information, PII information. Some of the countries and the continents have put forth some laws. In the case of Europe, there is GDPR law, which does not allow companies to utilize the personal information for your machine learning operations and so on and so forth. A proper processing should be done on the data before you actually use the data for your processing. And the amount of time it is going to take for cleaning the data and making it ready for your machine learning is a very big problem. In some cases, the amount of data available for the use cases were very, very less. If a hospital wish to create a model for building a cancer identification solution, typically the number of patients who are having with cancer and the kind of symptoms that they are providing could be very, very limited. And with that, if they want to build a robust model, it is very, very difficult for them. The number of data points that they have for their operations are very, very limited. That is another problem companies face. And in the case of existing data, there could be cases where the class imbalance on the data is very high. Meaning, in the same example of cancer patient, you could be having very limited number of data that you have for your machine learning model. And the similar way, if you are building an autonomous vehicles and so on and so forth, and there could be a lot of problems that the autonomous vehicles face in terms of when the car is driving at 100 kilometer speed, there could be 100 different variants. It could be weather, it could be your lighting information, and the vehicle which is coming from the front of you, and there could be hundreds of different parameters that you have to consider when you are building an autonomous vehicle. How do we actually simulate all those details uh, to provide a perfect solution as such? So these are some of the problems that are faced by companies. And to address this, there are various different companies and services are available. And the AI data market alone is expected to grow to around $4.8 billion by 2027. So that is the amount of opportunity which is available in the data market as such. Right. So we found all these problem. We have defined all these problem. So what is synthetic data? How is it going to actually help us on solving this problem? The the basic definition of a synthetic data is it is not a original data. It is a manufactured information rather than recorded from the real world events, meaning that synthetic data typically mimics the real world observation. That real world observation mimicked information will be used for training your machine learning model. We will see a lot of use cases where the synthetic data has helped build a large systems that we are using on a day-to-day basis. So synthetic data plays a very important role in terms of where you could not possibly get any data. You can utilize synthetic data as an option for generating this data altogether and build your machine learning model. So that is the beauty of using synthetic data. But then let us quickly understand, is synthetic data same as a data augmentation, or is it similar to a data randomization? So let us quickly look at a case and understand what differentiates synthetic data from the different approaches which are available in the machine world. Let's take a simple use case and see how these different names are actually different in terms of what it is trying to solve. Let's take an example of, you are looking at building a machine learning model. This machine learning model is going to recognize faces. You could be creating this for, say, probably a CCTV camera. You want to automate identification of the people on the CCTV camera, and you are building this face generation uh, model. So in this, if you are for training this particular model, you could be having a lot of source photographs of the people. And if you take the source photograph the people, and if you modify probably a person's color of his eyes and use that as another data set, that is an example of data augmentation. You are taking an existing data, you are modifying some features which is available on the data and use it part of your training. That is called data augmentation. Let's take the second case where you have two photographs of two person and you swap the nose from one person to another person, and it is the same set of photographs that you will be using for your application, but here the only difference is you swapped the nose part of the photo. So this is an example of data randomizing. You are randomizing the data, nose data, which is available part of your actual system. So then what is synthesis, data synthesis? Assuming you have hundreds of faces, using these faces as an input, you completely generate a new face, which is not at all available in the existing set of faces. That is called data synthesis. It will exactly match the features of what is available as a human being or a person. It could be a man or woman, but it may not be available on the whole set of images that you have taken for processing. So that is data synthesis. It is a synthetic data as such. The beauty of it is you have taken the original data, you are generating new data out of it, which could pass, which could be similar to the existing data, but it will not exactly match to any of the photograph that you are already having. So that is a basic premise, basic difference that you see compared to data synthesis with data randomizing and data augmentation. I hope it is all clear for you guys, right? So we are talking about data. So what are all the different type of data that we use as part of our machine learning process? Because that is the basic premise with which we will be going through the complete demo sessions and so on and so forth. I want to understand from you guys what kind of what all the different data types you've used as part of your machine learning process. Can I know what kind of a data types that you have used as part of your machine learning process? Anybody?
Data types mostly will give images or a CSV
Image,
data with lot of data which is more into fractional numbers, especially
right.
for the statistical data.
So agree, Mali. Yes. So you can classify. There are two type of data that you have mentioned. So the first that you can say the CSV data that you're talking about could be classified as a tabular data, a data which is in a tabular format. We all are familiar with this type of data, and that is one type of data. And there is another type of data called time series data. Time series data were pretty famous in terms of prediction exercises, assuming that you have stock market information. The stock market as such, every minute the price of your stock actually keeps on changing. You take let's say Apple's share. The share of an apple will keep on changing over a period of time, and as the time goes by, there will be a variations in the price of the data. So this information of capturing the information of over a period of time, the variations in the actual stock price, using that information you could utilize that particular data for predicting what could be the stock price of Apple in the future. So that is one other type of data called time series data. As you have mentioned, image data is another type of data where images are used for your machine learning operations. The another type of data is text data. So what is the difference between a tabular and a text data? So in the case of text data, these are pretty much used for conversational type of an interface, where if you are building a chatbot, and the kind of data that you will utilize for training your model would be a text data. It may not be a tabular data. It is a text data that will enable you to actually train your model and take it forward on that. So the next type of data is audio data. The image as such would cover your video part as well, in terms either images or the video of the data, and the audio data in terms of your text to speech, your conversation agents, your personal assistants. When you are working on such kind of use cases, you would require to work on audio specific data. As the complexity of the data goes higher in terms of if it is video or audio, it would increase the complexity of creating the data set for these particular use cases. So those use cases predominantly utilizes the synthetic data for their data generation as such. So now what are all the different approaches to generate the synthetic data? So there are three major approach for generating the synthetic data. So the first approach is called generative models, meaning you have a set of data, you have only limited amount of data that you got. Use that as an input, learn from that particular data, and generate new type of data which will mimic how that particular original data is available. I'll give an example. Say you have a stock market data information of Apple for say one year, but you wanted to mimic how the Apple will do for the next one month. You can look at understanding how the Apple has done for the last 1 year and utilize that information to actually generate the next 1 month of data. And that is one approach. The second approach is there are many tools and frameworks. We will see part of today's demo session, various tools and framework which can help you do the synthetic data generation. And the third approach is You could talk to some of the companies. They are focused on providing you the data set, synthetic sets as such, and they do the synthetic data generation process, or they could be doing a real-time data extraction process and share you the details that is required there. So these are the predominantly three different approach by which currently synthetic data is getting generated. Now let's start with each and every data type that we have looked at and see how we can actually uh, use multiple approaches for generating synthetic data. Let's start with the tabular data. So there are various tools are available for generating the synthetic data, and two of the popular one were synthetic data vault, which is famous for tabular data generation, and the next one is called tabgan, which is also a generative adversarial network based approach that also performs tabular data generation beautifully. And there are specific machine learning models which are focused on data generation, like GAN, CTGAN, WGAN, VAE, and all. VAE in terms of variable autoencoders and so on and so forth. And there are companies which are specialized on tabular data generation as well. So some of the reference companies I have provided here. So in the complete sessions that we are going to look at, we'll be focusing on some of the tools and the frameworks as part of our demo sessions. Okay. So we understand that there is a generative adversarial network which is helping us to generate the synthetic data for tabular data. Before we get into the demonstration of how that is done, let us try to understand how the GANs work at a very high level. So we all understand the fact that how a tabular data looks like. You will have a table which consists of multiple columns, and this multiple column has multiple rows of information that being added there. For example, uh, the screen that you are looking at is an example of a tabular data. In the tabular data, there could be some specific critical information. Your address could be there, your name, your gender, so many other personal identifiable information could be there. And it is imperative that you take care of masking, obfuscating this detail when you are working on synthetic data generation. And there could be another reason, another detail in terms of relationship between multiple tables. For example, you could be having a data which is available across multiple tables, and these multiple tables are connected uh, using specific relationships. While you are generating the synthetic data, you may have to stick to the relationship which are already defined. How do we do that kind of an activity? So these are some of the constraints, some of the problems. Let us see in the demo how we are actually solving these problems. Okay. So as I said, let us look at GANs, generative adversarial networks, how it works, and let us understand the details before we get into the demo part of this one. So if you look at the GANs are plays an important role in terms of generating synthetic data. GANs consist of two important pieces. One is called generator, another one is discriminator. Let's take an example of a face generation that I have mentioned. Assuming you have set of images of faces, and using the generative adversarial net, new set of faces, but these new set of faces should look like a face, but it should not be mimicking some of the features that are being available on my set of features. Mimicking in the sense they should not replicate what you have already have in the faces, but they should be classified as faces. I'll give an example. So all the celebrity information, say Obama, Clinton, all these people are there, and you put all their images as the real sample, and in the real sample, and you train this particular neural network. This discriminator is nothing but a neural network. Okay, train this, and this neural network basically learns that how to identify an image when an image is given, whether it is a real image or not, by using the real data sample that you have given. Okay, so that is what is happening. So the first step is you have real samples. Using that, you train your discriminator, and the discriminator learns how to identify whether set of images that are given is a real image or not. So that is one problem. So that is the first step. And there is a generator that that you activate by providing a latent space. This could be a noise with a latent space. This could be some basic set of information that you can provide, and you start generating fake samples. This is a second step that you do. So as you start generating the fake sample, you will give this fake sample to the discriminator. And once it is generated, the discriminator will try to classify, is it a face that got generated? If it identifies it is not a face, that means you need to actually do some more work in the generator. You need to refine the generator with modified noise, modified data. So what happens is this feedback will go back to the generator again, that the identified value is not a face. So then the generator will again generate a different set of image with modified set of feature, because until it generates a face which is identified by the discriminator as a face, it will try to modify the noise level, multiple routine that it goes, and as it improves upon on the generation, at one point in time the discriminator will identify that it is a correct one. So that is where it starts generating the faces which are almost equivalent to the real faces which you have already used for training. So this is at a high level how generative adversarial network works. I will repeat, there are two pieces to this GAN. One is called generator, another one is called discriminator. The first step is you train the discriminator with a real image. Because you train with the real image, it can actually identify and classify. If you give an input, it will say whether it is a real image or not, because you already trained the discriminator with that. Now, using some sample noise, you use the generator to generate an image. And now the image that you generated, it will be tested with the discriminator to see whether discriminator can identify this as a real image. If it is not able to identify that as a real image, then that means some more work has to be done at the generator, and it will change the weights, bias, and error details, and it will try to generate a new image, and it will repeat this process for many times. Repeat this process until it identifies the correct combination of weights and biases and the various features, that it is able to generate the faces which are accepted by the discriminator, that it is a face, right? So that is the basic concept. What I told is for images, assuming the same thing that you are applying for a tabular data. Assuming you have a set of tabular data, and you give that tabular data to a GAN and ask it to learn about it. And once it learns about the tabular data, what is the combination of the data that it is having, then you can actually request that GAN model, which is already trained in the tabular data, to generate new set of samples. And this, because it has already learned about the table data, it will try to spit out the data which is almost similar to the structure of the data that you have put for the training asset. So that is the overall concept of using GAN for your training process. So I hope that gives you a high level understanding. Do not worry about if you don't understand, because this is only internals of how the GAN works. But we do not need to worry about. There are a lot of Python libraries which are available, which can actually mask all this complexity and provide the feature that you need for your tabular data generation. So that is what we're going to see now. So let us start by looking at two different frameworks which are very important in terms of tabular data generation. The first one is called tabgan and the second one is called SDV. Tabgan is tabular generative adversarial network and SDV is synthetic data vault. And the code for this is already uploaded in the GitHub, and the link for the GitHub is already shared. And the original source code that I referenced is from the same location. I will be using their own source code for the demo perspective as such. So I've not done much of a modification because it is very good what the samples that they have given. Let me go to the demo part. So now first is, I hope you're all able to see the screen. So this is by using GAN tabular data generator. This tab GAN I have installed locally on my machine. And now this tab GAN has two different modules. One is GAN generator, another is original generator. We're going to look at GAN generator in this example. Assuming that you have some trained target test data with a random details that you are going to load this data. And using GAN generator, you can actually generate a data pipeline with the trained target and test data that you are getting. Okay. And the same GAN generator here in this line, you are not providing any parameters, where the new train 2, new target 2 will have all the default parameters put in place for generating the synthetic data. But you can define all the parameters that are GAN generator like this. See, there are a lot of details, and on which that particular data that you can as well. So now working, and at 20 it is completed the project, and this uh, there. Now let us look at the head. So this is the original train and original target. Now new train 2 is nothing but the new train 2 from, if you look at here, this is the generated data from the GAN generator, and new train 3 is GAN generator with the different parameter details. If I look at new train 2, so it has the data that is being generated. It's a very simple data. We will do little complex shortly. Okay, so the data gets generated new train 3. So which all are similar data. These are generated tabular data that got generated there. Okay, so now let's take an example of training the data with a specific type of information that I wanted to generate. So for example, let's take in this case a breast cancer information is a data set that I have in the sklan, and I will use that data for my generation. And I have a random forest classifier using which I will be verifying how well the model actually works. So this is the original data. So what I'm doing is I'm defining a method which is going to take a model and training data, X training, training, Y training, X test, and Y test data, and it'll do a fit and it'll share the metrics. What is the metrics that it is going to give me? Okay. So now first I'm loading this breast cancer data to the data set, and I am directly defining a random forest classifier, and this is the classifier I'm going to use. And in this, after using this classifier, I'm going to take the original data. The original data is the this breast cancer data which is available in the data set, and this data I'm going to put into the actual X train, Y train, and X test, Y test process, and I'm going to send it for prediction. That means I'm sending a original data and use the data for my prediction as such. Okay. Now this will give original data based prediction what is the actual accuracy level it has able to generate. Now what I'm going to do is, using a GAN generator, I'm passing the same X train or Y train split data, passing on to that, and try to predict using the generated data. Now the generated data will be new train to new target to. This is a generated data, synthetically generated data. And let us do a comparison of what kind of change in the metrics that we are getting from the original data and the generated data. Let me execute this. So now it is running, as you can see. So once that execution is done, a different epoch it is done with the CT GAN, and it is completed. So if you look at GAN generated metrics, it is up around 0.99. I am sure it is the initial metrics, which is nothing but with, I have mentioned here the initial metrics. With the initial metrics, it is 0.99. The GAN generated metrics is also 0.99. So the synthetically generated data is also producing a wonderfully equivalent kind of an output that you are expecting there. And xtrain.head is nothing but the original data, and now train 2 is the generated data. If you look at, you will not be able to see much of a difference in the kind of data that got generated from the synthetic data as such. Okay, so this is in terms of how you can use the GAN generator. So the next important case is in terms of utilizing uh, your SDV. Synthetic data vault is available there. Let me just restart my, wait a minute. So now SDVs were used for oh God, okay. So let me just start the SDVs so that so it is loading. By then I will close the old items which are opened. Okay. Uh, Great. So now let's quickly look at this in terms of how SDVs can be used for your generation of your synthetic data. So this is basically a tabular data that we are looking at. Let's look at the quick start example. Now the tabular data SDV as such is by already installed on this. Let me increase the size so that you can enjoy the item. I'm importing the SDV library for my process. For demonstration, SDVs provide two type of information. One is called tables, another one is metadata. The tables, we all are aware that what is the table that we use for our typical processing, storing of data, your rows and columns. The metadata information is nothing but it stores about the table in terms of what is the rows, what is the column, that kind of an information, and what kind of a relationship. These are the details that are stored in the metadata information. For the quick start demonstration, they have a default demo data available, and in this demo data they have included the metadata information as well. Let me quickly run and show you how it works. So the loading is completed in the tables and metadata. When I see what is there in the metadata, you can see it has three tables and it has two relationships that are defined there. If I want to visualize this, you can visualize this detail as well. For the demo perspective, you have user, session and transaction as a table, and the data are available there. And the tables as such, this is how you will define the tables in the SDV, synthetic data vault. So the users table, session table and the transaction table. So now what you can do is to quickly see and generate our own synthetic data. This is a sample data that is already available. There are three different tables are available there. You can define an object for this SDV, and I can create this fit for metadata and table using this object. So when I do that, it has created. What happened now is using the default data, the SDV object learned what is the structure of the data which is already available. Using that, you can actually generate new samples, meaning with this object that is already trained, you can actually go and say SDV dot sample all. It will give you a sample outcome for from the trained value. So now I have a sample. If I just print it, this would be a completely new type and amount of information that you get it as such. So there you could be asking, how did it identify the personal identifier information? How do I define the table? How do I actually get the data and all those questions? We will see them shortly, how to actually work on them. Now this is just a quick start to help you understand how it works, in terms of we are able to take the data and create a model for that, create an object for that particular SDV, and fit the data and the table information, metadata and the table information, so that you get a trained model. Now once you get the trained model, you can create samples, and when you create a sample, it will, it will completely create a new set of data based on the learning that it has done. Because this particular model is already trained now on the original data, you can save this data in this model itself, and you can save the model and you can use that model whenever that you want. It will save that information as a pickle file, pkl file, and you can use that for wherever that you want. And if I want to see only the 5 samples, and you can generate a specific number of sample as well, and it takes all the three tables and generates 5 different sample for them, right? This is a very simple quick start. Let us look into how the model, the pickle file that you created is gets saved here as such. Let's look at how our single table data gets generated. There are various different algorithm using which you can generate, where the prominent one is Gaussian coupler is an approach. CT GAN is also a popular one. Let me show from a Gaussian coupler approach, and consider that this is one way of learning the actual detail from the existing data. Let me increase the font. So now that uh, it is a similar approach. Let's say I'm loading a simple SDV demo and tabular data demo as an option. It has a default table called student placements table. I'm going to load that as a data here. Okay. If I want to see that, I can see that data, what information is currently available. The student informations are currently available here. Now, using Gaussian coupler, I create a model now and fit that model with the data that I have already taken. Fit the model with the data that I have taken. Once I fit that model, now the model learned what are all the different features which are there, using which it can actually go and generate new data. Now, if I say model.sample with number of rows 200, it is going to generate 200 rows of new data from the existing learning that it had and generates that data. Now, if I check the new data, it will have completely new set of data items which are generated from the previous learning that it has got. As simple as that, right? And similarly, how you saved, you can save the model into a pickle file and you can load that model wherever you require, and that will actually help you actually generate that model whenever you need. Now, in the existing previous example, we have generated this 200 rows, but we know that the student ID is a primary key. We don't want to repeat this particular primary key. It has to be a unique item that we wanted in the student ID. So we may have to, when the training process comes, when the generation process comes, we wanted to provide to the model that, hey, this particular column is a primary key. You should take care of maximum of only one data should come. Okay. So in the data.student ID, if you look at, that is the original one, you had only one value maximum count that you had. But if you look at the new data that is generated, there are student ID keeps getting repeated because we have not defined that it is a primary field, primary key. Student ID, only one student can have only one ID. So effectively, when we are creating this model, we can implicitly that a student key. So when you are generating the data, please take care of it. That is what we are saying here. So when you provide this and create another model, now you are with passing the details at primary key detail. Now it understood and it generates the data, and now in the new data that got generated, and will not see any repeat of the primary keys as such. That is what is verified here. There is only one data on the student maximum number of count that you can see. There is no repeated information available there. Okay. And we talked about anonymizing identifiable file contains your address, your phone number, or your gender. These are some of the information you don't want to share it with others because it's all personal to you. When the company gives the data for their machine learning process, you may have to anonymize this particular data. You don't want to share it with others. So how do I do that? So let's take a different data set. This different data set is called student placement with PII. So there is simply the similar data set, but you can see that there is one column called address gets added. So this address information is specific to the students who are there. So now if I run it, so it is the address information of all the students are there. But when I'm generating new data, let us see how the system actually takes it. So previously we have seen we are creating a model with Gaussian coupler, and we are mentioning only primary key. we are not mentioning any other details. I am running this and it has completed this process. But the problem is that the address could be matching with the original data. Let us see how many addresses are matching with the original data. If I look at here, there are around 200 addresses which are already there in the original data, and which is a repeat of that information. Because it is a newly generated data, I don't want to use the original address, because that is some personally identifiable information. There could be a real address which is there. We don't want to do that. And these are some of the PII information. Could be country, city, SSN, credit card number, expiry details, security code, email, telephone. All these are PII details. So what you can do is, you have an option of very simple one line of code you need to add: anonymize fields, where you specify, make sure when you are creating a new data, anonymize this particular address information. That's it. So when I run this, it has created a new model now with taking care of anonymizing the address information. And let's look at the sample, and it has the address, but to check whether is there a repeat of the address with the original data, and we found that there is zero matched data from the address point of view. Previously when we ran, there were around 200 addresses were matching. Now when we do this, we are not getting any address at all. So this is how you will use your uh, your uh, uh, your SDV for anonymizing your data and also providing a better data as part of your solution. So now whatever that example that we are seeing is basically an existing example of existing data. So how do I create this actual data along with this SDV? How do we load the data? How do we actually uh, create our own details? How do we actually create the metadata information and so on and so forth? So let us see. This is nothing but the relationship that you wanted to create. How do we do that? So this is a relational metadata information, and that is what we will see now. How we will create in the SDV a metadata for ourselves and create a table from scratch and load the data and create relationship in the metadata asset. So the same SDV I want to create, there are tables already there. Okay.
Prasanna, sorry, Prasanna, I'm unable to
Let's
hear.
see.
Is it your voice got
It's
dropped
taking
somehow?
time.
Yeah.
Yeah. Is it okay now?
Yes, Prasanna.
Yeah. Is it okay now, Mali? Okay. So now what we are trying to do here, I'm not sure where you lost the voice. Effectively, what we are trying to do is, how do we actually create a table with the metadata? How do we actually use that information for defining relationship in the table? This will be helpful in terms of generating new data using synthetic data vault as such. So now I'm importing the data, and once I import the data, here I'm taking only the table informations, and the table information, once it is loaded, I can actually display the list of tables there. As we know, there are three tables which are already defined there. Okay, but here I am defining a metadata from SDV. So the metadata is very important in terms of SDV, so that the SDV can understand what is the existing structure of data, based on which it can try to actually generate new type of data, new synthetic data as such. So I'm defining an object for the metadata, and I'm defining a relationship. I to the metadata. Now I'm going to call it as users, and the table name is users, and the primary key that I'm defining it as user ID. So once I run it, because it has already loaded the data, the columns which are available in the table. The only thing that I defined is there is a name called users, and my primary key is user ID. Only this information that I have done. And once I defined, so my metadata tables are loaded with users table. You can visualize automatically here. It has added this, this users table as well. Please note, I have not mentioned this country, gender, age. It has automatically identified because the table is already loaded in the list of tables list. Okay. So now, once I define the users, so you can get the metadata information of the users. It will give all the columns which are available in the table, the metadata information. So now the next thing is, how do I add a child? I want to create relationship. Where, how do you define the relationship is, let's say you are adding a new table called sessions, and in the session you are giving primary key as session ID, but this session is going to have a parent called users and the foreign key is going to be user ID. So you define this, and now when you look at metadata, it will have two tables, users and sessions, and there is a relationship that you have already defined that is also there. And now because you defined that, it will automatically take the columns which are available in the sessions table there. Now you wanted to create custom field properties. For example, I have a date time field. I wanted to make sure that it follows a specific format, where instead of day, month, year, I want the date time to follow year, month, date. You can specify that as well. Here I'm defining a transaction field, and I'm going to add a table transaction as part of the metadata. While I am adding, I am specifying that field metadata information as transaction field, and the primary key is transaction ID, and the parent is basically a sessions is what I'm defining. Once I define it, now I can go and see the details of what are all the different fields which are already added. Now if you look at here, the transaction as the table is added. The important part is the format is defined here, added as part of date time data as such. Okay, and it has the primary key, and all the references were also available there. Now if you visualize, it will clearly say how the tables are actually defined properly here. Now you can use this metadata and table for generating a model, like we have shown in the previous example. Generate a model, and from the generated model you can generate new synthetic data which will mimic the exact data that you have already had. Here in this case, this session, this one is basically to show you how to define your own table relationship and so on and so forth, generating tabular data. Now the beauty is you can actually generate a JSON outcome out of it, and you can basically have the JSON data read and shared it with anyone to use that for your own processing as such. Okay, so that is what covers how you can use the SDV synthetic data vault, which is an open source library. Both the solutions that we have looked at, both are open source library, which can actually help you define your tabular synthetic data and how you can use the tabular data for your whole processing as such. I hope you understood what we're talking. So the source code of that all are already uploaded. You can enjoy from there. So this is in terms of tabular data perspective. Okay. So now the next is, we have looked at the tabular data. Now next is the time series data. So the time series data as such, there are different models like time GAN and AR models which are available, auto regressive model, and you have tools. Even the same SDV that we have used has set of tools for your time series data as well. And there are some services like Gretel, mostly AI and all, where helping you generate. They are providing the generation of time series data as a service. Using that, you can actually utilize their service for getting the data. Before we get into that, I wish to actually give a explanation about what is a time series data. Okay, give an example and what are all the different pieces on the time series data that we wish to see there. So now this is an example of a time series data. This is basically New York Stock Exchange information for Apple from 2018 to 2019. I've just taken up only the top 5 rows in the actual data set. Now there are different columns are there. The different columns basically represent some information. The symbol represents Apple. There could be Google, there could be Microsoft. It will have its own symbol. The date is a continuous data where each and every working day of the New York Stock Exchange, that information is mentioned there. And here, the data which is going to be changing is the open and close and the volume information are the predominantly the changing field here, because you could be having multiple different open, close, and volume detail. And from the volume change, if you look at the market cap, the sector, and the industry, Apple is in computer industry and they are the technology stock. The information might not change at all for the period of the stock exchange as such. They could be always represented as computer manufacturers and the technology company and so on and so forth. Okay. So based on the type of information that we have in this, we can classify them, the data, into multiple category. For example, so there is an entity data. The symbol is an example of an entity data. Entity data represents for the whole time series set that you are looking at. There could be multiple entity data like Apple, Google, and so on and so forth. But each and every entity data has its own set of time series information, its own set of information that you need to focus on. Meaning, in the you could be having Apple, Google, Microsoft data for all the say the total data number of rows could be 30 million rows, and out of which probably Apple could be 10 million, Google could be 10 million, and Microsoft could be 10 million. So for the first 10 million that you see for Apple, all the data will have the symbol value of Apple only, but the other fields could value could vary as such. The next one is sequence data. The sequence data is very important in terms of ordering value, because it is date in which the actual details are captured. You cannot put August 2019 as the first value and January 2019 as the last value. So you should follow some ordering. So it should come from, if you are taking the data from January to December, then it should start from January and all the working days of January, and then the February, March, the sequence has to be followed. Then it is called sequence data. And the three columns that you see, open, close, volume, this is the data which we are interested on, because this is what will be learned by the time series analysis and generate a predictive value of what could be the data that these three can have. And there are three context data. For example, this could predominantly not change in the whole data set. I'm including market cap approximately you might not have a huge variance in the market cap as such. So I'm considering market cap also as part of my context information. So this is how you have a time series data. You have an entity data, sequence, data column, and context data information, right? So let's look at how we are going to use our SDVs for generating time series specific data. Okay, so now coming back here, we have seen here now SDVs has a time series data generation
Prasanna,
and
sorry.
probably yeah
Sorry,
yeah
actually,
yeah madam
even though it is can be time
yeah
based whatever it is, at the end it is looking almost like a tabular data, right? So for prediction
it is
system,
a test
whatever the input you're gonna give
yeah
it, yeah. Is there any extra deviation it is taking than what tabular data is doing?
absolutely because the kind of information that you are telling you have to define. Say in the case of time series data, even though it looks like a tabular data, the first thing is the ordering of the date should be proper, right? You agree?
Yes, agree. But the thing is, like, even let's suppose I want to predict after some time something.
Yeah, correct.
That
So
really
then,
dating a mandatory parameter where I should expect the next thing.
yes, yeah. So I agree that date might not be, but from a learning point of view, on
Hmm.
what date, what information, how the price has changed, that information
Hmm.
is very, very important in the case of time series information. For example, there could be seasonal data.
Yeah,
If you look at
possible. Yeah.
Apple, if
Hmm.
you look at Apple, their sales skyrockets during Christmas time because they give offers and so on and so forth. This information is that means that Apple sales and amount of stock price and could go up during the Christmas time because it is assumed that Apple sales will beat everyone else during Christmas time. Okay, so this could
Can I
be a
think as like
seasonal.
uh, see this
Yeah,
particular date, which it is
yeah,
helping like we are making either boundary or wait till cycle is over. Again, consider as
yeah.
a this is the second cycle, something like that. But the
Correct,
end it is a
correct.
table data. So
Yeah,
understand that the
end
cycle is over. So
table.
you can predict something like this.
Exactly. The difference is the machine learning system will not understand on what data it has to learn and what is the sequence data, and it has to order it to learn. For example, now we know when we are discussing December time that stock price is going to go up. So then we have to explicitly tell, hey machine learning model, I'm giving the sequence data. That means the date time informations are being provided as a column here. Use this column to learn about the actual seasonality details in the time series data. So that is a difference. Okay. So, but you don't need to do that in the terms of tabular data. Even though the representation of the data is similar to a table, but all these information that you are seeing in the screen has to be explicitly taught to the system before you actually start the learning process, so that when it generates the data, it knows that it is learning for Apple and this is the sequence information, and using this sequence information I need to learn the three data and generate that information for probably a January of 2022 or January of 2023, like that. Am I making sense?
Yes,
So
Prasanna,
this has
really
to be
right.
explicit, yeah, explicitly provided to them. When you see the demo, you will understand, because the reason why I'm introducing this is this has to be explicitly provided when we are learning the time series data using the SDVs as such. Okay,
Okay,
so
Prasanna,
I will
thanks.
show it in the demo. Yeah. So now, so PAR is nothing but probabilistic autoregressive model. So don't worry about the internals of it. It is considered that as a mathematical formula that you use for processing. So now I'm just loading a time series demo data. Now here, the same screen that you have looked at, I'm loading it here. Now I know that there is a symbol which is just an entity data, and you have date, which is a sequence, and this is the three information that you need to learn, and this is just a context information about that. Now that is what you have to define explicitly before you start the training process. So I have to define a column symbol as an entity column, and I know that the market cap sector all are context information. I'm defining that, and the sequence information is index. The date is the sequence index, and the data column, all our rest of the columns are data columns. Okay, so I am from the SDV time series, I'm taking the par probabilistic auto regressor model, and I am passing on these information there. What is the entity column, what is the context, what is the sequence column, and creating a model. And once the model is created, and I'm doing a fit on the data, so what it does, it learns the time series data. Now once it learns the time series data, the next step is to generate the synthetic data for the model. So if I just say, okay, generate one specific synthetic data. So now when I generate, let us see how it generates. So it is running, it is taking some time. So the reason why we are saying one is, here in the case of the data set, you could be having Apple, Google, Microsoft, like uh, so many of your data, that is stock information, could be available. So but we don't want all of them to come, but we want only one of that to come, part of our execution. So we are taking that and we are generating one, and once this completes, this should basically display something like this. This was a previous execution. It will complete, taking some time for the execution. So it comes out something like this, where you have the symbol, which is an auto generated one. So it has taken A as a company name, and the date it has automatically taken, and it is in a serious way, in the sense some serious informations are being provided, and it is taking the open close value, learning it from the existing data set. And market cap, consume sector, and the industry is all going to be kind of constant there. Okay, so this is an example of how, from learning from the existing data set, it is generated. Okay, so let it complete, we will run these things as well. So similar to the previous way, you can actually save the model to a pickle file and load that data again, and do that as well. Okay, it is still running. Okay, do that. So the second is, we will run this, but effectively the conditional sampling, the sense, now we don't, now if you look at here, the generated data is with some A and some data, something like that. Instead, you wanted to specify some specific explicit symbol, and you want probably the market cap sector to be following this rather than the computer service details. So that means explicitly you are giving the details to the actual model as such. So that is what is done by using conditional sampling. So in this case, I am providing the details explicitly. When I run, it will be able to use that information that I have provided for generation of the data. So now if you look at here, here there is set of data that gets generated with AAA and BBB, and it takes that electronic components and medical nursing services as an example. Okay, so that is an example of how this is done. So in the case of see, if you look at here, I'm getting A, and here in this case, I'm explicitly have to provide A, B, B, B. I don't want to do this. Let's assume I want to specify. You can have the company name, but the company name should have two characters minimum, and the two character, but maximum you can have four characters, or so four letters. So if I want to specify, then I can specify that as well as part of my advanced usage. Now here, the field type I'm defining as a regular expression that it is going to say my company name can be from A to Z. A minimum of two letter to maximum of four letters should be there. I am using this field type as part of my actual model creation, and using which when I generate, it will automatically take two letters symbol, and it takes the corresponding market cap sector and industry, but generates proper date, open, close, and volume details based on the learning that it has got. Okay. So, and if I want to control the length of the sequence, in the sense, here in this case, it is randomly taking AAA probably 100 items, and probably BBB it could give 200 items. But I wanted to control how many values, rows for the time series are getting generated. So this can be done by using number of sequences and the number of sequence length. For example, for each sequences, in the sense Apple, like Google, like that I want five different company details should come. By default, it is taking for each one 250 rows, but I don't want 250 rows. I want for each one only 100 rows. That can be specified by using sequence length. So number of sequence is 5, sequence length is 100. That will basically help me generate only for each sequence 100 rows of time series data. That can also be controlled by using that. Okay. The other thing is, can we generate the whole data without the context? If you go back to the presentation, what is the context? These are the context information. Does it have an impact on the whole generation? Absolutely not, because it is an added data that will mimic the existing data set that you have, but it does not have any impact on the final outcome that you are seeing. In that case, you don't need to worry about it. You can remove the context information and generate the data as well. So that is what is done here. Here in this case, without context, here we can specify I want the data only these details to be available, and no other information is required. So I take only this. I create the model without specifying the context detail. I say which is the sequence, which is the entity column, and I wanted to fit that model, and I'm creating a sample, and which is going to generate me without the context information as such. Okay. So if I want a specific symbol to come, for example, Tesla, a symbol name should be Tesla, I can specify that symbol name here and get that particular data with that sample as well. So these are some of an approach of how you actually solve time series data generation problem when you are working there. I see that the code is still working, which is a long one, I guess. So let's see. I think it has completed. Yes, if it is complete. Oh, it is still running. So, but effectively, you understand where we are going. So, let me just kill it. So let me just quickly run this, see whether it is running without any problem. If not, also I hope you get the idea about how to handle that details as such. I think that is kind of the whole environment. I may have to restart it, so then only it will work. Okay. So anyway, you get the idea about how it is working. So that is what is happening there. Okay. So coming back to this is how you actually work on time series specific data, generate the time series data. So two items that we looked at. The next is in terms of text generation. What is the purpose of text generation? Here, text generations are used for your chatbot creation, or you wanted to build a machine learning model which can actually do some conversational activities. For that, you may require a specific set of data to be generated, textual data, but these data does not need to be the original data that you are already having. It could be anything. So there are many text generation APIs which are already available, and these generation APIs can help you actually generate sample data for you to utilize there. There are models like GPT-3, GPT-2, which are available as part of many of the frameworks which are available. We have also looked at them in the previous cases. They can actually do that process very effectively. Uh, so now let's look at how do we actually do the textual data generation as such. So there is a DPI link which can actually help you actually do the textual data generation beautifully. And let me just take this link and go there and see how we are actually generating this textual data properly. Now, this text generation API, you can directly integrate it with your code as well. But for time being, as an experiment, you can specify the session is going great. It is a simple non-completed statement. When you submit, the machine learning model utilizes the GPT-2 for generating a text out of it. So it starts with the session is going great. So it completes the whole sentence, whole paragraph. Nobody is writing this. It is done by a machine learning model as such. So it is a generative model, GPT-2. We looked at the transformer session. In that transformer sessions, we looked at the GPT models. It is the same GPT-2 that was used for generating this particular data as such. You initiate the detail and it automatically generates this information. These kind of request response detail, the models could help you generate conversational AI specific data sets. And there are many models are available. And for example, you have solutions from Hugging Faces, Google, AWS, Microsoft, IBM, etc. All of them are providing specific services for you to utilize as part of your delivery as such. Okay. um, so the next is in terms of video synthesis. Video synthesis were very important, because many of the autonomous vehicles that you are seeing, and all the autonomous vehicles has camera systems in place, and we're constantly looking at the road and identifying any obstacles, any cars, vehicles which are coming, and based on that the autonomous systems takes action, so that it really understands how the actual images and the video stream which is coming is processed at a very faster pace. So some of the beautiful tools, or Nvidia has provided something called Isaac simulator. So this Isaac simulator enables you to utilize the simulator for various activities. This is an example of the isaac simulator, where if you are building a robotic system for, let's say, in a warehouse environment, you want the robot to actually navigate properly on the environment. You cannot create the robot and train it on the actual environment. Rather, you need a simulation environment, so that the robot can be trained very well in the simulated environment, and take that robot to the shop floor before it is being put into production. Because we cannot, if you want to train a robot on a warehouse, you cannot go to a warehouse and train that. You may have to do the training at the using the simulator. That is what is provided by the isaac sim. And the same thing can be utilized for, say, lip syncing exercise. So when you are speaking, you want the images or the avatars that you are creating as part of your games or anything, that should utilize the same kind of a lip sync process. You may have to utilize the simulators which are available to actually generate such kind of activities there. So these simulators predominantly help you do achieve what you cannot achieve in the uh, real world scenario. Another example is, in the case of face generation. Microsoft has done a phenomenal job. They have generated a fake images, and which are absolutely exact replica of a human being, but all these images are non-available. These people are just random images that gets generated. They are all not real people. The purpose of, they've generated over 10,000 plus images with the faces, and the purpose of them is many of the face recognition capabilities that they wanted to train, many of the features they are able to achieve them directly by using these synthetic faces. Instead of generating they capturing 10,000 people's photograph, they generate these out of the fly, use them for their own processes. And because it has that background environment and everything, which pretty much mimics the real image as such. From what you see in the left, how a template face is getting translated into a real image face. So that is the beauty of the current face synthesis that is being done by Microsoft as such. These are some of the examples in terms of how an image and the data specific to videos can be processed effectively using isaac sim and Microsoft synthetic face generators and so on and so forth. And this is another example of everybody dance now is an example of how a reference pose, the actual dance was done by only this girl, and you take the reference pose, and that reference pose is actually embedded on the actual detail, and you see that as if this person is actually dancing here, but effectively this is the person who is actually dancing. And as the reference appears, and anybody can be considered as they are dancing as such. So this is the beauty of how that GAN were helping in the video processing and the image processing as such. And these are some of the reference links that helps to understand the process how it is done. Okay, so we looked at tabular, time series, textual and video, and next is audio data. And audio data, the main purpose is basically for conversational interfaces in terms of how your Alexas were working, Google Assistants were working. How does the training actually happens? And it happens basically by using the auto-generated synthetic data as such. I have an example where Amazon openly said that, um, in the case study we will look at it, the Alexa was completely trained on a synthetic data, not on a real data set in the initial times. So this is an example of Amazon has something called a poly service, and the poly service enables you to utilize simple text to speech recognition items, and you can actually get that output out there. So for example, my name is,
Hi, my name is Joanna.
so effectively that data gets translated into something, a speech, and use that speech for your conversational interface development and so on and so forth. There are a lot of options are available for,
مرحبا اسمي زينة.
so that talks about different languages that you can control. Australian English, if it is a Nicole is speaking.
Hi there, my name is Nicole.
So that is how the different people all 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 speak, and that can be simulated. Could be a female voice or male voice. You can generate different countries how they speak, and that information can be simulated by using text to speech engines which are available there. That can be used for your uh, voice data synthesis as such. Okay, so now we have looked at a high level all the different type of data and what are all the different options and the services which are available, tools and technology that can be used for your synthetic data generation. You have tabular data, you have time series data, a text generation, a video synthesizes, and audio synthesizes. So these are some of the solutions which are available. Let's look at some of the interesting use cases available in the market. American Express, this is a reference link that I have provided for all of them. American Express did their fraud detection system completely based on the synthetic data that are generated, because they do not have much of a data about the fraud that has happened, and they utilize the synthetic data for identifying the fraud information from the data as such. If you look at medical simulation, there is a company called Charite. They've done a complete stroke prediction system, because you don't have many data points specific to strokes, but you know what kind of a causes, what kind of a medical conditions could actually cause the stroke, and they've built an end-to-end simulation framework on how they can actually predict stroke by using the various synthesized data, could be the images, MRI data, and the clinical data, which are all are being generated in a simulated way, and that were used for identifying the stroke, heart stroke information. And chatbot development. There is a company called MoveWorks. They have used complete synthetic data for their complete chatbot development workflow. So they have not looked at any external sources, because their requirement is specific to different companies. So to fine tune, they don't have that information. So they generated the data using synthetic data for processing it. And the next is, there is a Swiss insurance company. They used the synthetic data for predicting the churn of their customers, and how likely that that particular customer could go out, because the amount of data information that they have on why the customer is churning was not available there, and they used synthetic data for generating it. And this is a very interesting use case where BMW collaborated with Nvidia for a complete warehouse and the shop floor, that is the manufacturing factory. They built a digital uh, twin factory environment in a simulation mode, and on that they have trained the robots. They exactly replicated the factory, and that factory they've trained the robots to actually effectively manage the navigations and so on and so forth for the robot as such. So this was done using the Nvidia's platform, the ISEX sim that we were talking about. So using that platform, they have built this for the BMW as such. And Amazon Alexa has openly said that during the initial times, they do not have the data sets available. They have used the synthetic data for the complete end-to-end process. So that is how they could able to make the Alexa as it is now. These are some of the reference links that you can actually enjoy learning it about. And we are towards the end of our session. I would be very happy to answer any questions you guys have. Any questions, please? I hope all of you have enjoyed the session, and
Yes, sir.
thank you very much for joining. And um, good luck, and we will see in the next session on some of the interesting topic on the machine learning perspective. Thank you very much for joining.
Thank you very much,